sustainability of production. Thank you very much, Emilio. This is the 9th edition of ENO Forum, and it is the first time that I speak before this audience on the project. And it is my first time as a speaker here at ENO Forum, so I welcome this opportunity and I thank you for giving me this opportunity to tell you about the making of a European database. The slides are in English because this is the traditional presentation of the project that we normally use, but I will speak in Italian because, of course, I'm more fluent in Italian. The ECO-PROWINE project has this title. This is the full title, and it is aimed at identifying and applying enology practices which go in the direction of sustainability. As you know, sustainability is an environmental thing, but it is also meant in an economic and social way. It has a social and economic environmental. It is part of the call that you see on the slide. You see that it is about to expire, in that it started in September 2012, and it will be completed in September this year. The coordinator is Fundación Circe, which is represented by David Zembrana. It is a university foundation which is not specialized in wine making, but it is extremely competent in the field of energy saving and energy in general. These are the partners of the project, 10 partners, coming from 6 EU countries. Italy is nicely represented in that there are 3 partners, in addition to Vineyard, which is a small and medium enterprise. We have Euphoria, which is also an SME. It is a startup of the Catholic University Sacro Cuore in Piacenza, and the same university is also present as a partner. Then we have 2 Greek partners, 1 from Bulgaria, 2 from Austria, then Circe as a coordinator, and a Portuguese partner. These are the expected outputs. First, it intends to be an online web self-assessment tool, which is based on the life cycle concept. The intent is that of setting up a EU database, which is what I'm going to present to you. We want to act and serve as a set of information on available technologies that can improve environmental performance of wineries. This is validated, tested and then validated in a network of 105 pilot wineries in Europe. And our output is the creation of a sustainable label that identifies wineries participating in the project and which have started this improvement process. I told you I would focus on the database. The goal was that of collecting real data. These data are not the outcome of simulations or calculations. They are real data about consumption of input, and we talk about electricity, fuel, water, adjuvants, raw material for packaging, so the things that a winery purchases. Data were collected using a questionnaire. The questionnaire had 112 questions, 9 sections. Wineries were asked to provide data for a specific time period about vineyard management, winemaking, packaging, but also waste which is produced in the winery, which is also part of the life cycle. There were also questions about the socio-economic profile of the winery in a specific community, in a specific area. That was accompanied, of course, by additional data about the winery. The questionnaire was distributed at EU level by the partners and using the InfoWine database. Data were collected, selected, and because clearly it is not that everything which is collected can also be used. In some cases, data are not correct or real, so they were verified and validated. And that led to 90 full questionnaires, which is not a huge number, but which is representative. This led to the generation of a unique database. Basically, data pertained to information in invoices, bills, delivery documents, or data which the enologist is knowledgeable about, or the winery owner is knowledgeable about. 112 questions. The time required to completely fill the questionnaire was approximately 4 hours, and the majority of that time is needed to retrieve the document. So 3 hours for data recovery, 1 hour to fill in the questionnaire. I'm saying that because a number of wineries were sort of scared, thinking that they should devote so much time to filling in the questionnaire. But actually, it was not terrible, and the result was very interesting, so it was worth the effort. The reference period was May 1st, 2011 to the 30th of April 2012. We wanted to include a full here. What about retrieved data? This is a snapshot of the wineries with the geographical distribution.
Well, a good third belongs to Spain. Another third is for Italy, Austria, and Greece, Portugal. Contribute largely. Bulgaria contributes with 5% of the sample. And then you have Germany with a lower proportion, France too. So France is an important part of Europe, but it is underrepresented here. Also, the vineyard surface is telltale. You have 26% here, and then 32% between 6 and 20 hectares. And then you have cooperative wineries that, in general, have a much larger number of hectares in their estates. Now, number of bottles produced. There are some in our sample that are not bottling. There are wines, others that are bottling. Here it is from 3,000 to over 3 million bottles for the larger wineries. This allows us to say that the data that we have concern a very different range of companies and players on the market. This is a summary of the inputs, production inputs. These are only the main inputs, those that involve a meaningful, significant impact, from fuel to fertilizers to pesticides, water, ammonia, salts, processing aids, bentonite, yeasts, and so forth and so on, including bottling and packaging with plastic closures, corks, metal capsules, glass bottles, and cardboard for cartons. Now, This chart is telling us, first of all, that we have extreme variability. If you look at the standard deviation, it is very often above the average and not so much above the median. So you have a big diversity and a big difference from case to case. And so you also see the room for improvement in many cases. In some cases, the data is surprising. Data that were not even available before we looked into this issue. This is expressed in bottles of 750 ml. In terms of water, tap water or mains water used in the winery is slightly higher than what you find in the literature. It's 0.5 to 17 as a range, but generally it's 1.5 to 2 liters of water used per liter of wine. Now, the result is here clearly higher than expected, and while the figures for glass bottles are in line with what we know, with peaks, and we're not talking about sparkling wines even. This is another way to display the same set of data, which graphically is telling us what priorities we should be looking at. So this is the average. The red square is the average. And these are the quantities of each input in terms of units per bottle. You see the min and max and the distribution around the average. And you also see that there are enormous differences between weight of glass bottles and weight of other substances such as copper. So there's a very big variation in amounts per unit of product. Now, look at the distributions and how they behave compared to the average. Now, almost all the inputs, the main inputs, have the same distribution with a median, which is generally very low on the overall scale, far from the maximum end. And then the distribution follows this long tail. Copper is all centered around an average 0.5 grams per bottle. Sulfur, 4 to 5 grams per bottle. This is the purchase of these inputs divided by the number of equivalent bottles, or bottle equivalents rather. But there are a few cases where actually a lot more is used. Perhaps cases justified by weather conditions. Perhaps, while in other cases it's harder to explain the big gaps. Now, energy inputs. These inputs are not often measured in the literature. At least not in this way. This is fuel for tractors primarily. This is the frequency. The median is somewhere around 26, 27 grams of fuel per bottle. But with very virtuous users and users that are not performing so well. Electricity is another curve that does not reflect a normal distribution. Tap water 2, the median is 3.1, the average is 3.9, but with cases of very high levels of water consumption. Packaging. This is the slide that personally I found most surprising. Now, seeing how basically all the wineries that bottle their wines use large amounts of both glass, well, particularly glass, but cardboard too, and think of the box, the separators, all the cartons and cardboard that is generally used for packaging purposes. I had never really looked into this before. So this is the average weight of the glass bottle, 500 grams. So that is in line with what we know. But what is unexpected is the weight of cardboard per bottle. And you will see in a moment how essential they are in the overall picture. Now, here we have calculated the sustainability index. We've documented the quantities of each input, and using a data bank, we've translated each quantity, let's say how many grams, kilograms, or tons of, let's say, fuel, can go into an index that measures the climate change or ozone depletion or human toxicity. You have 18 indicators in total. So by matching the input quantities with the indicators, we obtained indices that were then grouped by type of resource. The ones in gray all converged into an air index, the green ones into a water index, and the beige ones into a soil index that contributed to a final global indicator or index, which was transformed, by the way, by our Greek colleagues to become part of the self-evaluation tool that is now available on the website, thus transforming each of these amounts and quantities into a specific environmental impact. Now, if you look at the incidence of paper, glass, plastic, bentonite, and so forth and so on, onto the air, water, and soil, you will see that there's a clear impact on the part of glass on all three resources: paper, which ranks second almost in all of these cases. Electricity is important, and then the others have a less evident role, with the exception perhaps of fuels. Fossil fuels have a higher incidence. Copper has a meaningful impact on air and water, not so significant on soil. And then corks. Corks have a high incidence in terms of water, not on the air.
Mettiamole tutte assieme e guardiamo l'indicatore globale. L'indicatore globale, poi lo spiegherà Zambrana, è quello che dà, diciamo, un po' la...
This all converges to this global index or indicator that measures the sustainability of individual wineries. Now here I have selected a few cases randomly to measure an average. Now they all average out into this general average, which is not representative of any of these specific cases. But let's discuss Winery C and Winery A. Winery C has 10 hectares of vineyards and 35,000 bottles produced. It's typically the small-sized estate family run, while Winery A has many hectares under vines and 3 million bottles produced. So you see the global indicator, which is pretty high for the family-run winery, while the large winery appears to be contradicting common sense, appear to be less impactful when it comes to the environment than the small ones. Now, this is the same set of data, but represented otherwise. The small winery has a higher impact because they use heavier bottles, probably not because they choose to, but because their supplier is not providing them with the entire range of bottles, giving them an option to choose the best suited weight for their products, which is something that the other winery appears to have looked into. So that makes in itself a big difference. Vice versa, the larger the winery, because they are packaging externally, so they package a lot more, with a lot more paper being used than the smaller winery. The other key case is copper use. The smaller estate was using a lot more copper, perhaps compensated by a different use of pesticides. But the relative weighting of pesticides, because of their smaller amounts, involves a less visible impact. The smaller estate, because it has separate vineyards over a larger area, consumes a lot more fuel than Winery A, where the vineyards tend to be concentrated together and to involve less fuel consumption. This is a way to read data in a more effective way. Now, this is a very nice chart which represents the costs. Of course, our study did not consider the investment in fixed assets such as the buildings, the tractors, or labor, marketing costs, which can have a big impact on the carbon footprint. So this is just the cost of the consumables used at the winery. Now, this chart shows on the same bar all the costs in terms of averages. Once again, that should be taken with a grain of salt, because this is not representative of all possible cost items, but the average of various wineries taken together. Now, the yellow part of the bar is the barrels. The cost is from 0.4 or 40 cents, euro cents per bottle. And the incidence is low because not all wines take barrel aging or oak aging. And barrels can be used for longer than the 3 standard years. What I was really very impressed to see was the blue section in our data. Essentially, that accounts for half of the entire cost. 75% of the cost is just packaging costs, packaging inputs. This part is the bottles, 45% of the total costs. This is the closures, foils, so basically the packaging, not including labels, I think. And again, they account for a big portion. And this is the cardboard, which is often regarded as a secondary cost item, but actually the cardboard have a cost that is higher than the input of the winery, where the lion's share is electricity, while the other very thin bars are the adjuvants and winemaking additives, which are basically not a big cost item. The green area is the vineyard in terms of fuels, fertilizers, pesticides, where pesticides have a big impact overall. This chart, once again, should be taken as an average, but certainly certain wineries are over or underperforming by far compared to this average. So, but reading this bar in general terms, we might say that the first two parts of the bar, the green and red area, is the amount, the proportion of the bar that we devote to making quality. And this is very hard to understand and accept. Now, my conclusions, and I apologize with David for taking time away from him. Now, these analysis could prove useful at a single winery level for comparison purposes, but the overall data might provide as well a unique source of information for people who look into sustainability and similar indicators, because the data is showing what big inputs can really have an impact and influence the overall performance. With this, I'd like to close my presentation, apologizing with the next speakers for taking away time from them.